Okay, welcome to surface area of composite solids with Mr. Lefley. Okay, so we're finding the surface area of this composite solid. It's made up of two solids, two rectangular prisms that are different sizes. We have the top rectangular prism and we have the bottom rectangular prism. So the first thing we need, now that we've identified that, we need to write that down in an equation. Okay, so we've got that the surface area is equal to the surface area of the top prism plus the surface area of the bottom prism. Now previously in the other videos we've found that the surface area can be found by multiplying 2 times the length times breadth, 2 times the length times the height, 2 times the base times the height. So we need to make sure that we're using that when we find it. So, to do the first one, we need to do the surface area of the top prism. Here we've got 2.5 times 1.8. So that's going to be the surface area of the base and the top. And there's 2 lots of that. Plus we're going to add 2.5 times 1.2. So that's this face and the opposite face on the other side. 1.8 times 1.2, and so that's the 2 end faces. Okay, so we've got to find the surface area of the bottom prism as well. That's done exactly the same way. We have 5 times 3, which is the bottom and the top. 3 times 1, which is the 2 end faces. And we've got 5 times 1, 5 times 1, which is these 2 side faces. That comes out as 46 centimetres squared. The next thing that we need to do is we need to find the common area. Now because this rectangular prism is sitting on top of this box, the area that's actually underneath the box isn't counted in its surface area. Now we need to take that into account twice because in both of these calculations here we've found the whole surface area of the bottom rectangular prism and the whole surface area of that, and we've included that in our question. So if we just add these together now, we're actually going to be incorrect. So what we need to do is we need to find the common area, okay, which is going to be this bottom face, 2.5 times 1.8. Now when we substitute that back into our solution, we need to make sure that we multiply that by 2. Okay, so you can see here we've got 19.32, 46, which comes from the surface area of the bottom prism, and we're subtracting 2 times that bottom face surface area. Now there is another way that we could work this out, and I would like you to have a go at that. Pause the video, just think about another way that you could work it out and bring your solution to class. So there's 4 basic steps to finding the surface area of a composite solid. The first step is to identify the solid that makes up the shape and write an equation. That describes the surface area of the shape. And find the surface area of all the solids. Part 3 is to find the surface area that is shared in the shape. And 4 is to subtract the number that you found in step 3 from the number you found in step 2. Okay, so here's the we do question. So this is where you need to have a go at this first before you continue on the video. I've put down the first step, so I've written down the equation that makes up the surface area of this shape, and it's up to you to find the area of each of the surfaces and the common area. Okay, so if the area of the curved surface, 2 pi r L divided by 2, you need to substitute the values in for r and for 2. Okay, so the value for r is 20, and that comes from the fact that the diameter is 40, so we just halve that to get 20, and the length is 15 centimetres. We divide that by 2 because we're only using half the curved surface. And that gives us 300 pi centimetres squared. Now the reason why I'm doing that is just so that it's an exact value, but because we're multiplying by 5 and by pi, and it's an irrational number, that means that we're going to get a ridiculously long answer. So the next thing is we need to find the area of the semicircles. Now, semicircles, so we use 2 times a half times pi r squared. Again, substituting the values for r, which is just 20. Substitute that value in, and that gives us 400 pi centimeters squared. So the next step is to find the surface area of the prism. Okay, so your solution to finding that should have been 2 times 40 by 15. 40 by 15 gives us the end face, and the other one, that's why we're multiplying by 2, plus 80 times 15, 80 times the height of 15, plus 40 times 80. So 40 times 80, that will give us the bottom and the top. It comes out as 10,000 centimeters squared. The next thing we need to do is find the common area is the rectangle that lies between the cylinder and the rectangular prism. 40 by 20, which equals 800 centimeters squared. Okay, so then we substitute the values back into the original equation that we've written. So substitute our value for the curved surface into the equation, our area of the semicircles, our area of the prism, and we're subtracting the common area. Now you'll notice here that we haven't multiplied it by 2, and that's because when we found the area of the half cylinder, we didn't actually include that rectangle that you would find on the bottom of the half cylinder. So that should be our answer. Okay, so this is the you do question. Okay, remember the 4 steps. First one is that you need to identify the 2 solids that make up the composite solid. The next step is find the area for each of the surfaces. Then you need to find the common area, and then substitute all your values back into the equation, and then that will give you the answer.